So, good afternoon, friends. As I have told you that we will be solving more problems based on the equilibrium constant. There are two types of the equilibrium constant. When the term that is used in the molar concentration Kc, and if a partial pressure is used, then it is the Kp. So, I will take the problem first. Uh, Copy this problem. Uh, Paste this problem. Let's read the problem. Following results were collected for the two experiments involving the reaction at 600 degrees centigrade between gaseous sulfur dioxide and oxygen to form the gaseous sulfur trioxide. This is experiment number 1, the values are given. This is experiment number 2, the values are also given. What we have to do? So that the equilibrium constant is same in the both the experiment. Remember that in both the experiment, the equilibrium constant value is same. We have to show that. For that, first, what do we have to do? We have to read the problem two times. We have read the problem. So what is the reaction? Reaction between sulfur dioxide and oxygen to form the sulfur trioxide. Okay. So we have to write this reaction first. So what is the reaction? Sulfur dioxide, SO2, that is SO2, that is in the gaseous state, plus oxygen, O2, always exists in the molecular form, that is O2 in the, again it is the gaseous state. The reaction, that is the product that is forming is the sulfur trioxide, that is SO3. Since it is the equilibrium reaction, again this reaction will go backward direction. Therefore, SO3 again it decomposes to give the SO2 plus O2. Right now, next thing is that to balance this equation, reaction, the number of sulfur atom this side is only one and this side is only one. Number of oxygen atom 2 plus 2, this 2 plus this 2, that is equal to 4 number of oxygen this side. Only 3 number of oxygens are this side. Therefore, we have to balance the equation by multiplying particular factor. I will try to balance this equation. If I multiply this equation by 2SO2, then again multiply this by 2, then let's see the balanced whether the given atoms are balanced or not. SO2 sulfur, in this case there are two sulfur atoms, this side also there are two sulfur atoms, therefore sulfur atoms are over. Now the next are the oxygen atom, this side 2 into 2, 2 into 2, that is equal to 4, plus these 2 oxygen, that is equal to 6 oxygen. Therefore this side also 2 into 3, 3 into 2, that is equal to 6 oxygen. Therefore all the atoms in these reactions are balanced. Now this reaction can be used for the calculating the equilibrium constant value. Since the concentration values are given in the concentration, molar concentration, not in the partial pressure, therefore we can write it as the Kc, that is equilibrium constant in case of the concentration. We know that. What do we know that? That is product divided by reactant, SO3 gas. Since it is gas, no problem, because it the molar, the concentrations are given in the molar. Therefore concentration term SO3 raised to power 2, since multiplication factor is 2, therefore divided by SO2 again concentration is written, since the concentration are given, raised to the power 2. Next is oxygen, O2, only one power, single power. Therefore now next point is that we will try to solve this equation. We will try to solve the equation in the both the experiment. So Kc in experiment number 1, Kc in experiment number 1, this is experiment number 1 and this is experiment number 2, and this is equation number 1. This equation number 1 we use for the in the both the cases, because the reaction is same, only the concentration value are changed in the experiment number 1 and 2. Therefore Kc is equal to SO3 square, SO3 concentration square. SO3 concentration is 3.5 molar. So 3.5 raised to 3.5 raised to 2 divided by SO2 square. SO2 concentration is 1.5 molar. So 1.5, how much it is? Raised to the power 2 into multiplied by how much? O2 concentration, equilibrium concentration, that is 1.25. 1.25. Remember that we are taking the equilibrium concentration value, not initial concentration value. Since the initial concentration before the reaction start, that is the initial concentration. After forming the reactant and product, that is the equilibrium concentration when the reaction is reached at the equilibrium. So let's calculate Kc is equal to Kc is equal to Kc is equal to 3.5 square. Let's calculate 3.5 square is how much? 3.5 square value, that is equal to 12.25 12.25 divided by 1.5 square multiplied by 1.25. 1.5 square, let's see how much value. 1.5 square, that is equal to 2.25 multiplied by this 1.25 multiplied by 1.25, that is equal to how much? That is equal to 2.81, that is equal to 2.81 2.81, that is equal to 12.25 divided by 2.81. 12.25 divided by 2.81, that is equal to 4.35. 4 point, that is equal to how much value? 4.35. Therefore, this, for the experiment number 1, the value, equilibrium constant value Kc comes out to be 4.35. Now same equation, same reaction they have used, but the concentration, molar concentration have been changed in the experiment number 2. Let's try to calculate Kc for the experiment number 2. Kc for the experiment number 2, Kc is equal to experiment number 2, this SO3 square from the this equilibrium constant reaction. SO3 square is 0.26 molar, 0.26 molar square divided by SO2 square. SO2 how much value? 0.59 square, 0.59 square multiplied by how much? O2 concentration. O2 concentration is 0.45 0.045 molar, right? So 0.26 square, how much will be the value? 0.26 square, that comes out to be 0.0676 0.0676 divided by 0.59 square. Next value is 0.59 square, 0.59 square, that is equal to 0.3 0.3 0.3481. So 0.34 into this value 0.045 0.045. Therefore, that is equal to multiplied by 0.045 that is equal to 0.0676 divided by 0.01566 0.01566. Therefore, let's calculate the final value. 0.0676 divided by 0.01566, that is equal to 4.31. 4.31. This is equilibrium constant for experiment number 2. This is experiment number 2, and this is equilibrium constant for experiment number 1. Therefore, 4.35 and 4.31, all the two values are within the experimental error. When we do perform some experiment, if you repeat the experiment, there is always some error, that is called as the experimental error. So all the values are in between the experimental error. Therefore, we can say that the equilibrium constant value in the both the experiment are same, nearly same. This is all about the problem number 1. Let's try to solve the problem number 2. I will take the problem number 2 from the collected problems. So problem number 2, I will copy problem number 2, copy. I am pasting the problem number 2. So let's read the problem number 2. What is that? Problem number 2. Problem number 2. So what is this problem number 2? Calculate the equilibrium constant for the reaction H2 gas plus CO2 gas the equilibrium reaction, that is forming H2O plus H2O gas plus CO2 gas at 1395 degree Kelvin. If the equilibrium constant at 1395 degree Kelvin for the following reaction are 2H2O, that gives H2 gas plus O2 gas, 2CO2, O2 gas, CO gas plus O2 gas. In experiment number, in this reaction, for this reaction K1 is 2.1 into 10 raised to minus 13, and for this reaction K2 is 1.4 into 10 raised to minus 12. So how to solve this such kind of problem? So I already told you that while solving the problem we have to read the problem two times. First understand the problem. So what is given? The given problem is that H2 gas plus CO2 gas equilibrium reaction, that is giving H2O gas plus CO2 gas, CO gas, sorry, CO gas at 1395 degree Kelvin temperature. At that temperature, this reaction is carried. But the additional information is given for this reaction. What is the additional reaction? 2H2O gas, 2H2O gas, that is converting into H2 gas plus O2 gas. Again, this is the reversible reaction, that is forming again 2H2O. 2CO2 gas, that is converting into 2CO plus O2. Again, this reaction is converting into 2CO2 gas, right? So let's write the equilibrium constant for this reaction. For this reaction, Kc is equal to what? Kc is equal to product divided by reactant, concentration of product divided by reactant, concentration of reactant. So H2O concentration, since there is no multiplication, therefore H2O multiplied by CO, that is gas, divided by product reactant, that is concentration of H2 multiplied by concentration of CO2, right? This is, suppose this is equation number 1. Now let's try to write the equation for this above reaction, the given reaction, these two reaction. The equation is 2H2O, that is in the gaseous form, equilibrium reaction, it is converting into the 2H2 gas plus O2 gas. O2 gas. Let's try to write the equilibrium constant for this reaction. Let's try to write the equilibrium constant for this reaction. Equilibrium constant, let's try the K1 for this reaction. Let's say K1 for this reaction. K1 is equal to, what is that? The concentration of H2, since there is multiplication 2, therefore comes out to be 2 power 2, O2, only O2, there is no multiplication term, therefore only O2. Now for this H2O, concentration of H2O raised to the power 2. Suppose this is equation number 2. Now the next reaction is what? The next reaction is 2CO2, it is converting into the 2CO, that is again in the gaseous state, this is also the gaseous state, 2CO plus O2, that is again in the gaseous state. So let's write the K2 for this reaction. Let's say equilibrium constant for this reaction is K2. Again, as usual, concentration of product, that is CO, this side, CO raised to the power 2 multiplied by this concentration, O2 concentration, divided by reactant CO2, concentration of CO2 raised to the power 2. Raised to the power 2 comes out to be 2. Suppose this is equation number 3. Now we know that. What do we know that? The equilibrium constant is like this, H2O H2CO, right? So what comes out to be, if you divide K2 by K1, then we will get the nearly same value. If you divide equation 3 by 1, divide equation 3 by 1, divide equation 3 by 1, what we will get? We will get K2 divided by K1 is equal to K2 value, concentration of CO multiply CO square multiplied by O2 divided by CO2 square. We have written this. Now while writing the K1, we cannot divide, we just divided by multiplication. So this H2O square comes out to be upper side, H2O square divided by this H2 square H2 H2 square into concentration of O2. Concentration of O2. Now similar terms will be get cancelled. So this O2 and this O2 will get cancelled, right? CO2 square is there, CO square is there. There is just 2 square. So let's rewrite this K2 divided by K1. K2 divided by K1 is equal to what is the remaining? CO square into H2O square H2O square divided by what is remaining? CO2 square. CO2 CO2 square. Now look at this. Suppose this equation number 4. Look at the equation number 1 and equation number 4. There are similar terms. Here is S2O term. In this case S2O term is there. Here is CO term. In this case CO term is there. The downside CO2 term is there. There is also CO2 term is there. Now one more thing we are missing here. H2 square is remaining. H2 square is remaining. So in this case H2 is there and in this case also H2 is there. But all the terms are in the square format. Therefore the equation can be written. This equation can be written in this format. That is K2 divided by K1 is equal to what is first? H2O. So H2O square we can write. H2O square we can write. Next term is CO. We can write CO, concentration of CO square. Next term is H2 this side. Therefore this term H2 square and CO we can write CO2 square. So we can write CO2 square. There is also CO2 square. Now if we compare this equation number 4 and equation number 1, the similar things are there. Therefore we can say that this is only except there is a square. Therefore we can write instead of this equation K2 divided by K1 is equal to Kc square. We can write Kc square, that is concentration number 1 square, right? Therefore we know the values of this K1 and K2, right? K1 and K2. K1 is for this reaction is this one, for this reaction K1 is this one, and K2 for this reaction is this one. This reaction, for this reaction K2 is this one. The values are given, so we can write directly value. So I will take this Kc this side. Kc square is equal to K2 divided by K1. K2 value is how much? 1.4 into 10 raised to minus 12. 1.4 into 10 raised to minus 12 divided by K1 value. K1 value is 2.1 into 10 raised to minus 2.1 into 10 raised to minus 13. Therefore Kc square is equal to I will clear this board first so that we can have the uh, uh, some space to write more things. So I grab this board first. So Kc square so Kc square we can write from this equation, from this suppose equation number 5. Equation number 5 becomes, if you take the square root of both the side, Kc is equal to under root of 1.4 into 10 raised to minus 12 divided by 2.1 into 10 raised to minus 13. Now I will rearrange this equation again. Kc is equal to, this equation becomes Kc is equal to I will reduce one factor from this, that is under root 1.4 into 10 raised to minus 12 divided by minus 12, I will convert this into minus 12 value. So 0.21 into 10 raised to minus 12, we can write 0.21. I have shifted this point, so that is equal to 0.21, 10 raised to minus 12. This minus 12, this minus 12 will get cancelled. Therefore Kc is equal to under root 1.4 divided by 0.21. Therefore 1.4 divided by 0.21, 1.4 divided 1.4 divided by 0.21, 1.4 divided by 0.21, that comes out to be 4.39, and if you take the square root of that 4.39, Kc is equal to, the value comes out to be, let's wait, how much will be the value if I take the square root of this value. uh, uh, the value will be 2.22. The value will be 2.22. 2.22 will be the equilibrium constant for this reaction. The value comes out to be 2.22. So this is one of the problem. We have more problems in the textbook. I will be giving one problem for your assignment, and we will try to solve the. We will go to the next topic in the next video. Thank you. Bye bye.